All right. Well, thank you to Jennifer and Andre for some fantastic opening comments and inspiration to set the stage for the amazing work we're about to share. I'm Jen May Gray. I am the director of the Dow Sustainability Fellows Program in my first year, as you earlier heard. And I will be introducing the first three teams that will be presenting this morning. So to get us started, Team 1 has the honor of warming things up, and they will be sharing their work on analyzing farmland for solar potential, which they did in partnership with the Washtenaw County Climate Reality. So I'll welcome up Team 1, please.
Thank you, Jen, for the introduction. So as Jen stated, our group has been presenting and studying analyzing farmland for solar potential in Washtenaw County, and we had the fortune to partner with Climate Reality Project. Climate Reality Project is international, but we worked with their Washtenaw County chapter, and they are today, we are going to be speaking about background, then methods, then our deliverables, and finally, the impact of this work we've been doing. A little bit about the project background. Washtenaw County is pursuing strategies to build out renewable energy systems. We've been doing this to accomplish the Washtenaw County objectives of carbon neutrality operationally by 2030, and then as a community by 2035, which are ambitious goals, but we are striving to achieve them. Climate Reality Project is a fierce advocate of climate energy solutions, and their local chapter is directly involved in this net zero transition. And one key assumption that we did have to make during this project, if you're keeping up with legislation in Michigan, the House Bill 5120 does change some siting from a local level to a state level, but due to the timing of that legislation pass, we did focus our project with the presumption of existing infrastructure before that House bill. We started off our project by doing some literature review on social, environmental, geospatial, and financial measures. For social, we focused on equitable benefits and burdens across the communities, transparency and how that plays a role in public perception of solar energy. For environmental, we focused primarily on LCA's life cycle analyses about solar and how they play a role in farmlands and how they compare to agriculture existing systems. For geoprocessing, we looked at different workflows and analysis processes that were used for similar projects. And financial, we looked at cost-benefit analyses for foregone profits of agricultural activity. Nivi and I had the opportunity to work particularly at some community outreach and engagement and meeting participation. We did this by first organizing ourselves and figuring out which meetings actually were talking about solar on the agenda. And then we took it upon ourselves to attend some of those meetings. We sat in, we listened and heard what the community actually has to say about solar in their town, solar in their farmland, and there was a lot of opposition, there was a lot of dissent, there were some vocal participants in those meetings, but there was also support in other township meetings. So it was really valuable experience to better understand what barriers we're facing as we look towards the future of utility scale farmland solar.
Revathi and I had the pleasure of diving into GIS to power our land suitability analysis. We started by pre-processing several public data sets. What that means is that we isolated the agricultural and rural residential parcels. We removed conservation lands from consideration, and we selected only those substation, transmission lines, and water bodies that were within Washtenaw County boundaries. Next, we utilized Model Builder for our land suitability analysis. Model Builder is a visual programming language in ArcGIS Pro. It allows us to string together several geoprocessing tools and create an automated workflow. This is actually, it sounds boring, but it's very consequential for the scalability of our project because it allows policymakers, community members, and energy developers from other municipalities to duplicate our model and customize it with their own local data. Lastly, we took the output from Model Builder and we put it into an interactive web-based mapping application. This allows the public to access and use the outputs of our analysis. Here's a closer look at our model. You can see in the blue, those are our inputs. We utilize solar radiation, substations, transmission lines, water bodies, and land use to determine a land suitability value. The next step was a series of geoprocessing operations to make meaning of this data and process it and analyze it for our problem statement. This included things like performing a distance allocation on water bodies to make sure that any potential sites were considering their access to water for cooling and cleaning. Lastly, we integrated the several insights from the different data sets into one composite overlay layer using the weighted sum tool. Within this tool, we ascribed each input its own weight, and we determined these values using insights from our literature review. And this brings us to a screenshot of the web-based mapping application. We'll dive into the details a little bit later about the user experience, but you can see here that our land suitability value per parcel is displayed, and the application itself also employs a combination of widget tools and data visualization to ensure that users can navigate and use this information for their own purposes. It's one thing for the public to have access to renewable policy and information, but it's a complete other task to make sense of it and feel competent and confident while engaging in the siting process. So we wanted to make this application in order to help policymakers and community members digest what exactly determines an optimal solar siting location in their county. They can also filter the data according to a number of characteristics to make it meaningful to their role in and attachment to their community.
So on the financial side, the idea is simple: to convert power generation estimates to dollar figures which people can understand, compared to talking to them about megawatts generated. What we did was a cost-benefit analysis approach, where the benefit is, of course, the revenue from the solar land lease that farmers would obtain, and the cost is the foregone profit from agricultural productivity. On the revenue side, we of course looked at different factors, and since you can't model all of them, we took the approach of basically pegging the least sort of parcel of land with the least amount of energy generation estimate to the lowest land lease rate, and then you increase that in a straight line approach. On the cost side, we looked at 4 different crops, the 2 top field crops in Michigan and the 2 top fruits that you have. And we looked at the commodity prices for them over the past year and the production cost of them, both fixed and variable. And what we hope this allows is almost like a scenario analysis where you can talk to farmers and tell them that if this is the revenue you have from leasing and this is what your We understand this is not the only consideration here, but this is a big one for most people. Coming to the deliverables, we have multiple deliverables. First, of course, is a report which has all our literature review about the technical, financial, and social considerations, the methods we have used, the impact, and some results and recommendations. The GIS web and PDF maps, which are interactive and which can be used by the public to hopefully look at which land parcels are most suitable for solar. The community outreach pamphlet, which hopefully outlines challenges and how to engage communities in resolving these challenges. And lastly, the financial model, which hopefully engages conversation with farmers in terms which they can readily understand.
The link to our web-based mapping application will be available through our final report, but I wanted to include a few examples of ways that you can use it in the presentation. We have things like individual data tables for each parcel. We have charts that depict solar or power generation potential and land suitability by location. And you can also filter the map by land suitability value in city and township. One of my favorite tools that we utilized is the summary tool, which allows us to use power generation potential readings as you zoom in and out of the map and or filter it by these characteristics. So it's very interactive and user-friendly, and it also dives into what exactly this map means for the future of solar in Washtenaw County in some description areas.
Speaking a little bit more on that community outreach solar pamphlet, this is something that was not an original deliverable in this project, but as we engaged in these community meetings, we realized that there was a lot of information gap, both for policymakers and community members in regards to how to approach solar and how the process is conducted. So we prepared a brief pamphlet that we can provide to those community members and policymakers that can help guide that process. Okay, speaking a little bit more on impact, the impact of this work, looking at some of the UN climate goals, it's contributable to affordable and clean energy, industry innovation, and an infrastructure, sustainable cities and communities, climate action, and finally partnerships for those goals. And we look at emission reduction, which is an obvious one to most of us, that renewable energy would be better on the climate, livelihood enhancement, especially for those farmers, and then of course, more engagement in social governance. We have acknowledgements today to Climate Reality Project, in particular Chris Olson, Parth Vaishnav, Sarah Mills, Joanna Matthew, Bridget Gruber, and Jen Magaret, and then of course Dow. So thank you all.
Sorry. Okay, we have some time for questions. We can pass microphones for anyone who has one.
Hi, great job, guys. I was wondering if the financial incentives were enough to convince farmers to transition their land use over, like even if there was a significant financial benefit over growing crops, were people like making the change based on that?
No, as I said, there's multiple considerations. One very simple example is consider a farmer who's 25 and is starting his agricultural journey versus someone who's near the age of retirement. So for them, how they look at that land is very different, right? The person who's retiring, for them, the lease revenue is just money which they don't have to really work for. Versus someone who's at the start of their career, they have 25 years to consider in terms of what they can get in terms of prices, what the land can be used for. So it's not the only factor. A lot of other people also consider there are challenges with solar development in terms of using it for, you have to set up time for construction. Some people don't like that on their land. Others think of whether the land could be used by the children. So as I said, the financial analysis is really to start a conversation on terms which they would more readily understand than, let's say, megawatts. But we agree that it is not the only factor.
Really nice work. The map that you showed on the usability of the land, as I understood, the big one, the previous one, there seems to, if I get it right, there is a correlation between suitability value and population concentration. Is that am I getting it right? Like Ann Arbor, which is probably the highest population concentration in that area, has the highest score.
Mm-hmm. So that is a result of our pre-processing. Since we're focused on farmland solar potential, we isolated all of the parcels that were up for discussion, only those being that were agricultural or rural residential. Yeah, so we looked at the zoning code specifically, and that was a part of our data integration. There were a variety of values that went into our land suitability analysis, and land use was one of them. So those areas that might have been ruled agricultural, but still were characterized in land use maps as more urban development, or whether they were brush or wetland or whatever the land type is, that also factored into our analysis.
Positively? Because I'm still puzzled, right? Because, I mean, just thinking on the land in that, the cost of land in the Ann Arbor area financially to the financial guy now should be higher, which makes the financial less attractive.
I think there's a color discrepancy. The black is zero.
Yes.
Oh, the high sustainability value, the high suitability value, the least likely.
No, the darkest color that we have present on the map is this one that I have my mouse over right now, which is the 4 to 8 category. Ann Arbor is under the 0 category, and a large component of that was that this is before House Bill 5120. So we were looking as well at zoning restrictions. Ann Arbor city limits do not allow for utility scale farm
I get it.
solar
I get it now.
operations. So
Thank you.
yeah,
Those
Thank
are
you.
excluded
I got
values.
it. I got it now.
sorry about that.
That's okay. Thank
Good
you.
question, though.
Great work again.
Thank you.
Thank you.
We have time for one more, if anyone.
Hi guys, great job. As a member of the other farming team, I was curious what you learned from farmers and the communities. You said you went to the community meetings, which I think is a great way to engage the community and ask them about this topic. Did you hear challenges, or what did the farmers think about doing this in a general sense?
Definitely, there was a lot of challenges. We went to 4 community meetings because they only had solar agenda. The first thing was lack of distrust amongst like community members, the farmers, especially towards the policymakers. They were not okay with solar projects coming on their farmland, which has been included in our report also. Plus, they do not have the technical nitty-gritties. They know, like, do we have recycling facilities, or do we have information on if there can be solar leaking from the connection, the pipes going there. So they had a lot of questions on that. And Akira and I were sitting and just being observer, but that is one of our recommendation going in, that you need to educate the farmers why they need renewables on the land, and because of the transition going to 2030. And also there was some positive information, like Sylvan Township, farmers were proactive towards installation of renewables. They discussed more on biomass, geothermal, wind energy also. So 3 township hall meetings, not a very positive output, but one definitely had. So it's a mixed review, I can say. Kiara, you want to add anything?
Yeah, I just would second what Nivi said. There's a lot of opportunity for engagement with these communities to provide information to them as they want it, both on the financial models that Nicholas discussed, as well as how likely their property is to be a place that solar developers will be wanting to pursue renewable energy, and also understanding what that process looks like from beginning to end, from the very steps of some solar developer knocking on your door, getting an opinion from you, to the very end steps of there being policy in place that allows for solar integration, and there being an interconnection agreement with this developer, and there being an agreement with the landowner, and there's not enough information publicly accessible that goes through the whole process from beginning to end that provides clarity as people are moving forward. And I think that there's just a lot of information gap, which makes people hesitant towards embracing renewable energy.
I would say it's not a very negative attitude, but definitely the need to be informed more how you can co-create farmlands with solar development or renewables. That's it.
Okay, thank you, Team 1. Great start.
Thank you.